So hello again, Level 2 Physics students, NCEA. Continuing on with Level 2 Mechanics. Last lesson we looked at Newton's first law. Today we're going to look at Newton's second law. So one concept that we'll also touch on later is the idea of what momentum is. So what is momentum? It's the object's tendency to continue moving, which is kind of related in a way to inertia. So inertia is the resistance of an object to change its movement, whereas momentum is the object's tendency to continue moving. And momentum is the mass of an object times its velocity. So in terms of Newton's second law, what that's basically saying is that the force is proportional, or the total net force is proportional to the change in velocity of an object, okay, or its acceleration, times its mass. Okay, so the force equals, or the net force equals the mass of the object times its acceleration. Okay. So force equals mass times acceleration. So the symbols for force are F, symbol for mass is little m, and the symbol for acceleration is A. And the units, of course, from our previous lesson, are force is newtons, mass is in kilograms, and acceleration is meters per second That's why the SI units of newtons are kilograms, meters per second So the second law is actually a bridge between unbalanced forces, or forces, and the motion that we've also been exploring. Okay, so the force equals that mass times the acceleration, for example, that you see in the equations on the right. So these are the equations. Remember the kinetic equations, the equations of motion, which you have to be familiar with. So don't forget those. We will be using those when exploring the second law in class. And in terms of net force, we'll spend more aspects or focus on that in the next lesson, but it's important to know that any time that a net force is not zero, okay, the object's not at rest or moving in a constant velocity, then there'll be acceleration in that direction. So for example, for a car accelerating to the right, we have the reaction force going up, the weight force going down, and the engine force to the right should be greater than the force of friction or air resistance or drag to the left. Okay, that's how you do a free body diagram for acceleration of a object, or in this particular case a car, to the right. And finally, in terms of equilibrium, that means that the forces are balanced. Acceleration is going to be zero. Okay, that means two different things. Potentially, it could mean that the object is not moving, okay, it's at rest, or that the object is moving at a constant velocity. Okay, that's introduction to at least Newton's second law.